We're going to convert some Cartesian coordinates into polar coordinates. So it's worth keeping in mind that polar coordinates look like this. There's going to be the first coordinate, which is r, the distance from the origin, and then theta, which is the angle from the positive x-axis. It's always handy to sketch these, so we're going to do that. And the first one we'll look at is 1 and root 3. Now 1 and root 3 is about here. If I were to draw triangles in, then that would be my line from the origin. Here's my line from the x-axis and from the y-axis. This distance, when I consider this would be root 3. This would be 1 to make my point of 1 and root 3. What I need to do, therefore, is work out the value of r and the value of theta, which I've coloured in red. Remember, if I have a look at my standard table of angles, I should be able to work out most of these, and if they're not in the standard table of angles, then I'd use technology. So for the first point, tan of theta equals opposite over adjacent, which is root 3 over 1. And therefore, theta must equal 60 degrees or pi on 3. As for r, remember Pythagoras tells us r squared equals a squared plus b squared. In this case, we'll set a as root 3, so it's root 3 squared plus b squared is 1 squared, which is 3 plus 1 equals 4. So therefore, r equals 2. If r equals 2 and theta equals pi on 3, then 1 and root 3 could be expressed as 2 and pi on 3 in polar coordinates. For the second point, which I'll do in blue, this is right on the x-axis at the point 2 and 0. For this, we know that for the Cartesian coordinates of 2, 0, my angle theta is 0 because I'm right on the x-axis. There's no deviation away. And we know the distance from the origin is 2, which means the Cartesian coordinates and the polar coordinates are the same. And this is a distance of 2 at an angle of 0 from the origin. That's an unusual case, and you'll find that when a point is on the x-axis. For the third point, which is 0 and negative 3, we're looking at a point down here. In this case, I can do one of two things, and this is where we keep in mind that polar coordinates are not unique. There might be a certain number of coordinates that you could use to describe the same point. Here again, we can see the distance from the origin is 3. So for the point 0 and negative 3, we know that r equals 3. If I wanted to, I could draw my angle going clockwise from the x-axis, which would make it negative, and therefore this angle would be negative pi on 2. So an acceptable answer here would be 3 and negative pi over 2. Conversely, if I wanted to, I could go the other way from the x-axis, in which case I could also consider this point as 3 and 3 pi over 2. If you found this video helpful, please subscribe or like. Thanks.